Good morning, everybody. My name is Maida, and today I'm going to explain you about the modern studies that what would happen if the methane is being released due to the global warming. So now, while we're discussing the methane gas, we have the following questions. We will discuss the following 4 questions in detail in the following video. The first one is how methane accelerates the global warming, where does it comes from, where does it goes into the atmosphere, and what we can do to prevent it. So let's get started. First, I'm going to share with you 2 data. The first one is going to be the global data and the other one is the US data. So now let's see how the global data looks alike. So when you look at the global data, for example, for all the gases, about 65% of the carbon dioxide comes from the burning of fossil fuels. The carbon dioxide may also contribute to the forest trees, I would say, or the forest fires. And the others, that's about 11%. The fossil fuels, such as the cars and all that you know is the industry which uses fossil fuel, leads to 65% globally. The next major gas is the methane. And that is my topic for today. So methane gas contributes about 16%. And then we also have nitrous oxide as a contributor. The nitrous oxide is a subside of 6%, and the rest chlorofluorocarbons and all other makes up hairs. Now looking at the US data, for instance, what US data is doing, it's a little bit different. So the US data, the carbon dioxide contributes about 80%. And then if you look at the methane, for instance, it is about 11%. And the nitrous oxide is about 6%, and the rest chlorofluorocarbons, water vapors, all fits in here. So it is a bit different from the global data. Today, as I told you before, that my topic is about methane, so let's talk about the methane. So when we look at the methane, for instance, there are different sources of the methane. And let's see what are the major ones. Industries and the things which are contributing towards the methane, the major contributor here is the natural gas. Right. It's all the petroleum industries or the oil industry. We talk about that is about 33%. So these are the major contributors. So it is a major contributor of the chlorofluorocarbon. The second one are the landfills. Before that has actually the fermentation. So let's talk about the fermentation first. Fermentation is basically around 22% the contributors of methane. And we have the landfills. The landfills also are one of the major ones. Landfills are all the garbage, we dumped on the landfills and started decomposing and produces a lot of methane gas, and that's about 20%. And also we have the livestock, which also the livestock manure, I would say, and that's basically about 8%. And also we have one more, and that is roughly about 9%, is the coal mining. I don't want to miss that. And the other ones comes here. Now, when you look at the livestock, combined with, this agricultural industries filled by the fermentation. For example, 22% in the livestock, all of this, and when you combine all of this is preventable. But that's what the pictures look like. The natural gas, is the major contributor, but then the others are also any. And now we look at what can happen. So we say, for example, what is happening currently is that because of all these greenhouse gases we have in that atmosphere, we have all relays and the temperature to 1 degree Celsius. Only up in the 2016, and it's a major rise because 1 degree Celsius can make a lot of difference. So that's very important to know. Now if you look at the earth, for instance, what is happening, and I hope you are able to see here. So say for example, we have the permafrost in the North Pole which are covered with the ice and the snow. And we have the Antarctica over here, and the same thing with the ice and snow. And under the permafrost there's a, it is called the clutterate. And what is it? The decomposition of the decaying, that the dead animals and the plants materials, right? So what is happening here with that is the decomposition produces methane here. The decomposition after the dying dead bodies of the animals and plants which were buried under the snow is the cause of methane here. It produces the methane gas here. But because that strap is lower here, so this is all in the appeal here. The methane is trapped in this, reason a lot of methane, and the same thing is in the Antarctica. So all the methane is trapped in Antarctica and the North Pole in the permafrost. And what happens when the temperature starts rising because of all the gases we have? This all started to heat now from both the North Pole and the Antarctica. This is resulting in, rising the sea level is going up. That's not only the problem. When the temperature starts rising, the methane gas is gonna be unstoppable here, and it starts getting out into that atmosphere. And that is the biggest concern here. So as the temperature rises, now we are at 1 degree Celsius up. Say if we go to the 2 degrees Celsius up, it can accelerate the introduction of the methane from permafrost regions, both from the North Pole and the Antarctica. And there will be accelerated now because the methane is 20 to 25% more number closer. The number is 25% more or 25 times more, but then the CO2 and greater than CO2. So what does that mean? That this will accelerate the global warming at a much faster rate. So if we reach 2 degrees Celsius, we are seeing a lot of methane. We are seeing a lot of methane which is coming out in the atmosphere from these reasons. Not only that is under, then you see that the ocean is 70% water on the earth, right? So a lot of the oceans and a lot of decaying matter in the ocean floor that also has CH4 and trap because of the methane, because of the decomposing, the organic matter. So not only this, but the oceans will also start warming up and they would start pumping into the methane from ocean's floor. So we have 3 major contributors. Sitting, the wetting is as soon as the temperature starts rising, this is going to come out. So this is going to be the monsters because there is going to lead a very quick rise in the temperature. So from 2 to 4, 4 to 6, and then 6 to 8 degrees Celsius can go very quickly. And the biggest concern, if you want to learn from history, when we talk about, for example, PETM, Paleocene, Eocene, thermal maximum, what we learned from there is that, the temperature rose to 8 degrees Celsius. We had 50% all life from going extinct. At that time, and that time period was 20,000 years ago. It took 20,000 years, 55 million years back to took 20,000 years to end this temperature to degrees Celsius, but which wiped out 5% of all the life from the earth. So what we were doing right now is much more worse than even PETM time, which is much more faster because when we look at 1 degree Celsius, when you look at, for example, 1890, you see we had the carbon dioxide level at the time was about, 240, and when we see in 2016, we are 400 parts per million, which is equals to the rise in the carbon dioxide level, which is rising the temperature. And here already raised the temperature to 1 degree Celsius. But when we talk about the methane, that's 25 to 20 times more important than CO2. we are gonna end up this melting from both North Pole to the South Pole. And if you look at the data, in 2006, we have about 3.8 million of methane released into the atmosphere from the permafrost trees. This points to the global warming or human-induced global warming. And if we do not do anything to stop our greenhouse gases into the atmosphere and stop this rise in the temperature, now we're gonna be in an uncontrollable situation. We would not be able to save this planet Earth. And I'm talking about the life on this planet Earth. We have seen that in the history that 50% of the life was wiped out and went extinct 55 million years back in the PETM time, and we know for sure that this time is much and much more worse than that time because it's all human induced. It's not natural. That was a natural time. This is the human induced time. This can be prevented if we pay attention. If all the governments, all around the globe, we have to stand up and, talk about it and do something about it as soon as possible. If we do not do anything, I think it will be too late, and it is already going in that direction. So that was the kind of, discussion I wanted to have in the documentary, and I wanted to see if we can pinpoint or specify on the methane, which is 25 times more important, and how we can help stop this process of, methane coming out from the permafrost region, both from the North Pole and in the South Pole, and from the oceans. And what we need to do here is basically making up discussions at the global level. How do we make sure that we can stop pumping these gases into the atmosphere, and all at least at the end, stop this happening if we start realizing that methane is a much higher at rate than what is happening right now. Then we all know where we're heading. We should have now came to an end, and we all know that where we are heading. Thank you so much for your hearing. Thank you.